Hi, good evening everyone in South Asia, and good morning to everyone in Boston and United States. This is the continuing interview series with the LabVIEW personalities and LabVIEW champions from all over the world. I think you guys must have enjoyed and learned a lot from the journey these personalities as well as the LabVIEW champions has taken in their long career using LabVIEW. And not only that, like they have been using LabVIEW, they have also contributed a lot into the community and shaped the way we use the LabVIEW today and the user experience that has been affected as well. So my name is Gurung. I'll be the host for the interview today, and I have very, very special guest today. You cannot believe it. He has been contributing to the community for a long, long time. He's not only the CLA, but also the CLED and CTD and the LabVIEW champion. He's no other than the Jon McBee, the founder of Compose Solution. Yeah.
Oh, thank you very much, Ram.
You can introduce me.
Yep. So my name is Jon McBee, and hard to top that introduction. I'm a LabVIEW champion and a certified architect and a CPI, which is one of my favorite things to be. I really like interacting with people and training people. I'm also the founder of Compose Systems, and we're a smallish LabVIEW consulting shop. I won't make this a Compose System sales pitch, but happy to answer questions on it. A little bit about how I got into LabVIEW. I think my story is probably pretty similar to a lot of other people's stories. I got a degree in physics and wasn't sure what to do with it, so I went and worked at a higher energy physics lab in Colorado. And my job was to automate physics experiments. And I had to learn how to write software out of necessity. I'd never had any exposure to software development at all up till that point. And one of the first things that I had to do when I got to the lab was work on the automation of a steering mechanism for a particle accelerator. And so I get there, and my advisor basically said, here, this is some software that another graduate student wrote. They couldn't get it to work right. This is a thing called LabVIEW. Why don't you try to learn LabVIEW and try to make this work? And so I inherited this huge, gigantic block diagram in my first exposure to any programming, my first exposure to LabVIEW. And I just assumed that was how LabVIEW was supposed to look, which was not right. And so huge spaghetti code didn't function right. And I had to sit down and figure out, A, what is LabVIEW? B, what is this supposed to do? And C, what is it actually doing? And so my advisor, after I just looked at it for a week or two and said, I think I understand what the goal is, and I think I understand how to write software with LabVIEW. He said, I'm going to Argentina for a month. When I get back, let's see if you have this working. And I was naive, and I thought, hey, if he says I could have this working, it must be possible. It turns out his expectation was that I would not have it working because they'd been spending the better part of a year on it without making any progress. And so in that month, I was able to learn enough about LabVIEW and understand the spaghetti code enough to rewrite it, to actually just do a refactoring effort before I knew refactoring was a word, and to make this thing work. And so my advisor gets back, and his mind is blown. Like, I can hit a button and I can make this thing move. And at that point, my mind was blown too, because I never would have guessed it was possible either. And I've been hooked ever since, being able to write software to control the world. Not as scary as it sounds. I should have said it differently. So that was my first exposure to software, and I fell in love with it. So I never was formally trained in a textual language or any language. And that may be why I was so open to learning LabVIEW, because there's a lot of pushback from outside the community on graphical programming, but I love it. It maps well to how I think. And so from there, I worked in the high energy lab doing cool things for a couple of years until funding started to go away. One of the downsides to working in academia in a lab. And so I had a decision to make. Do I try to stick with a physics career, or do I try to make a career out of LabVIEW? And at that point, I didn't know what I didn't know, and I thought I was good, which is dangerous. And I decided to make a career out of LabVIEW. And so I was out in Colorado, and I worked at a few places in Colorado. I worked at a wind engineering place, controlling wind tunnels and doing really cool things. They had this house on rails out in Wyoming, and then they would mount different things to the roof, like solar panels or different types of shingles, and they would rotate it based on where the wind was coming from to take measurements. And so I got to do really fun stuff like that. and all along the way, I get better and better. And I work with people, and I found out there was a community. I ended up working with Tom Ferraro out in Colorado, and we founded a user group out in Colorado. And it's just, I think one of the things that has allowed me to keep progressing in my career was I always look for opportunities to learn and people to learn from. And so I've had some really good mentors along the way. And over time, I just kept learning and learning. Still learning today, obviously, and was able to build a career out of LabVIEW, which I at one point thought might be possible, and now here we are. So ended up moving to Massachusetts just to continue the story down all the way up to today. And I worked at an integrator called Bloomie Controls, and it was an awesome job. Fantastic people, just a group of very smart, very driven people. And I worked there for a few years and got to know everybody and learn about consulting, which I'd never done before. Consulting, I fell in love with consulting because you get a new problem to solve every couple of months or every year. And that's really intriguing because, like I said, I like to grow and I like to learn. And so when I left Bloomie, I went and worked for a place that was making a product where the software was in LabVIEW, a biotech place. And they ended up losing funding again, story of my career. And so I worked at a semiconductor place briefly, then I started Compose Systems. And right now I'm at Compose Systems. There's 5 of us. We're all CLAs. We're all, I think we're all highly competent, right? I think we are. And we all get along well together, which is equally important to competency. And we just try to solve hard problems with LabVIEW. We work a lot with high-tech startups in the area, so we don't do a lot of the typical applications, and we don't do really any automated tests. It's a lot of new product development with LabVIEW, and it's super interesting and really, really fun.
Wow, that's really, really like interesting journey you have told, John. Like, so you have discussed that like you started as like working at the physics lab, and then you moved on to working for different companies, and you are working in a now firm, and then rather than like integrating any projects or data acquisition or something, you are mostly into like a product development. This is the like a little bit newest theme like I found in the like I haven't encountered actually like in the previous interviews I've taken with like other professionals. So what are the different the challenges or the experiences you had like working alone or like working in a team, and then like what differences you found while working in a product yourself or like supporting for like other customers?
Yeah, so I think a huge thing worth addressing first is working alone versus working in a team. Working alone, you're in a bubble, even if you don't realize it. And I think the majority of the people in this community don't realize there is a greater community out there. They don't realize there are better ways to solve problems. And that's usually because they're either working alone at a company using LabVIEW for something, or they're working on a small team at a company using LabVIEW for something. And a lot of times those small teams will look towards the most senior person. And if the most senior person isn't constantly trying to go out and bring new ideas in, then they stagnate. And they don't know there's better ways to solve problems out there. So early on in my career, I did realize that I was in a bubble and that there were better ways to solve problems. And I tried to address it by starting a user group in Northern Colorado, where I was at the time, and bringing other people from the community together to talk about problems that they needed to solve and solutions for how they solved them. There still is a fantastic user group called Alarm, a little bit further south in Colorado from where I was up in Fort Collins. And so I got to go to Alarm meetings, and I got to see LabVIEW champions talk at those meetings and very experienced LabVIEW people. And I tried to take that atmosphere and that level of technical ability and competency back up to this little user group we were starting in Northern Colorado. And just being in that environment helped me get better, helped everybody get better. And again, once you realize there are better ways out there, you seek out ways to learn them. And the best way to learn, sorry.
Yeah, it's fine.
I got a text message and it vibrated my phone. The best way to learn is surround yourself with really smart people. And so working at Bloomie was a no-brainer for me because I got to surround myself with really smart, competent, dedicated people. And that made me better at my job. Same with Compose Systems. I try to work with people that I admire and that we get along with, and we make each other better. And that's also what kind of drives me to be I try to be a member of the community. I try to bring content to the community and talk to at the CLA summits and at NI week, and devote my personal time to trying to put content into the community, because I've experienced it and gained from it in the past. And so it's hard, because how do you get access to people in a bubble? You can't, right? By definition, they're in a bubble. They don't realize that there's anything outside the bubble. And I don't know the answer to that. We're trying, so that's one thing we're talking about doing at Compose Systems right now, is trying to figure out a way to reach more people in the greater Boston area to start with, and not calling it a user group, but maybe trying to do something like, we were just going to hold a code review. Anybody who's interested in LabVIEW, come to our code review. We're going to start by looking at our internal tooling. We have a bunch of internal tools that we use for our projects, and talk about the decisions that we made that make these tools worth using, and then encourage other people to bring their code in to the code review. And so instead of having a user group, which ends up typically being somebody with a PowerPoint up in front of a group of people talking about things they may not have the context for, we want to try to get people inside code and encourage people to ask questions. And that's mainly driven by the fact that it's how we learn best from each other. Is if someone has a cool idea, they jump into LabVIEW, they write something, then we all go and look at it together, and we ask questions about the code and understand it that way. So, but still, how do we get people to come and do this with us? Maybe this interview will help. I don't know. I hope that it does. But I don't know how to reach people in that bubble just yet. It's something that we're working on. So, yeah, go ahead, sorry.
Yeah, John, like that is like a very interesting point as well. Even in India as well, like there are like lots of customers. Yeah, many people. Like even like we cannot even imagine like how many people in different industries, they are all using LabVIEW, but they are not actually integrating the best practices. Like you said, that key code review is actually a way that many people do not realize that there are like a better way to doing different things, and then. Sometimes like they will realize only after the code doesn't work anymore. So like I know like that is one of the best way, like what you have said, like when you give the code review to them, like they will only realize that okay, this is a better way to do it. But like I think like there is like only another way of challenges. Like many people think that you should not fix it until like it does not gets broken or something, like it's useless or something. Like what do you think, like what can be done to that context? I think like you must have faced these kind of challenges while you are like developing some solutions.
Yeah, so this is where I have landed, and I think people would like to argue with me about this as my guess. So my whole ethos to writing software is, our job as software architects is to understand and manage change. And that's it. It's that simple. We have to understand the change in the software we're writing. We have to understand. So Robert Martin, I'm sure you're familiar with him. If people in the audience aren't familiar with him, look up Robert Martin. He's got books, he's got videos online, blogs. So one thing that Robert Martin has said in the past is software has two values. And the first value is that it's soft, right? Software. It's meant to change. And the second value is that it's going to solve our customers' problems. A lot of times people invert those, and they say, my first job is to solve my customer's problem. And you end up with code that might be fragile. It's hard to change, it breaks easily, but it works right away. But change happens. I don't care what people say. In my 15 years of writing software, change happens. Even with the smallest VI that you write thinking, oh, I'll never use this anywhere. This is just something that's going to exist on its own. It's not true. You're lying to yourself. And so because I believe that my main job is to manage change, all of our software that we write is built to be flexible. And even how we interact with people, we interact mainly through Scrum. And so it's very iterative and very agile. And the way we engage is we're going to just know there's change. And so if someone comes to us and says we want a fixed price quote, we're kind of weird because we'll say no. Because what I like to tell people is with a fixed price quote, more than likely, neither of us actually understand the problem we're trying to solve. Even the customer doesn't fully understand the problem. So how can I give you an idea of how much money it's going to cost or how much time? I mean, I can give you a ballpark, right? And we try to do that by saying we think it's this many sprints. But even trying to say what what the work per sprint 8 is going to be, you can't. You can't. And if you think you can, you're lying to yourself. And so our entire approach to software and business is agile, managing change, and planning for change. And that's how we work. And so you're right, people do write fragile code, and everybody starts there because you have to make something work. But people don't understand the actual investment of time on the back end. Once I've delivered fragile code, how do I maintain that code? How do I let it change with my customers' changing needs? You really can't. And so we invest the time up front. And that has worked out well for us, and this worked out well for me throughout my career as I've learned to do it that way, is to plan for change and let that drive how I write my software. So how do you get there, right? It comes back to where we started. You need a mentor. So one of our biggest problems that we have to address is when we engage with a customer. A lot of times they already have someone using LabVIEW in-house. Because why else would they even want to work with LabVIEW, right? Because they have to already know about it. And that person using LabVIEW in-house has been in a bubble, and they don't know what they don't know. And so we come in with our frameworks and our reuse code, and we like to say that we've kind of built a programming language on top of LabVIEW with all of our abstractions that we bring that are just pre-written that we can then use for the problem domain to solve that customer's problem. We have to teach that customer how to use our way of using LabVIEW. It's like learning another language. And that's not easy to do, but it's a worthwhile investment. And NI has this center of excellence, and we're not a member, we're not a center of excellence because we're just an integrator, but we try to have the same approach to writing software, where when we work with a customer, it's not formal, but we try to make that customer a center of excellence inside their own company, where they write software the way that we write software. And it's not as terrible as it sounds. I mean, sure, our frameworks are complex, but it's because they address complex problems, and they're highly abstract separation of concerns patterns built on top of the actor framework in some instances, and built on top of layers and layers of our own IP in other instances. But when you approach the problem space, you use our tools like you'd use any other tool to solve the problem that is in your domain. It means that all of our projects kind of look the same. Whether it's embedded or whether it's just on a PC or whether it's across multiple PCs, our code looks the same. And I think that's true for most integrators these days. Everybody has their own flavor, but I think that's true. And so it's easier to teach them how to write software our way, and it's worked so far. And actually, one thing we've been kicking around as an idea, and that I'd love to try out, is a new business model where, say we have a new customer, they've got a small team, and we've worked with them in the past on a project. They like how we write software because it's clean and it's fast and it's agile. And they want their team to be able to do that too. What we want to do is we want to embed, say, me as a member of their team for 2 months or 3 months, where I'm more or less a member of their company for 3 months, and I lead their software team on different projects. We don't even have to do a project from conception to completion. We just work together as a team, and we bring ideas in like unit testing and how to properly use source code control and issue tracking and continuous integration and all the architectural bits of how do you actually sit down and decompose a problem and start to think about how to write it in software. And all of these ideas are built around rising the tide to lift all boats, where we firmly believe that our approach to writing software is worth learning and worth implementing, and we want to help people do it so that we can step away and they can keep being successful internally with our tools and keep making progress. I don't know if I answered your question. I kind of went on a tangent.
That's like a really awesome point, like John, like that's very interesting and everything. So that is like a really awesome like approach to like how you support the customer for their success and everything. That's a different part. So like let's move a little bit towards the community side. John, like you have been involved with the community a lot, like you discussed before that. You were part of the community in the Colorado as well, if I heard that correctly. So like, when was the first time like you actually made the LabVIEW champions, and then the value of the the community? You have already mentioned anyway, like it comes to it is going to help you out, come out of your like a bubble, and then try to explore like what are the different things and everything. Can you please like discuss a little bit in detail about like the value of the community?
Yeah, so I guess I'll talk a little about the Champions program first. So when I first started learning LabVIEW, I came across the online community instantaneously, right? Just a quick Google search and you're there. And I was blown away by the amount of people in the community online on the NI forums providing support. And then you start to recognize certain names, and then you learn about this thing called a LabVIEW Champion, and you kind of put it on a pedestal, and you don't really know what it is. And for the longest time, I kind of thought of LabVIEW Champions as they were the best at what they did in the world. I'm not saying they're not, but now that I am one, I think that a LabVIEW champion is more like a king's champion, where it's our job as champions to champion LabVIEW to the community, right? And so being a LabVIEw champion is kind of like getting your driver's license. It's a license that almost allows you to be put in front of people and proselytize to people about LabVIEW and talk about why you love it and help them love it too. And so that's kind of how I approach it, because of all the things we spoke about already with how I value a community is being kind of a feedback loop where being part of the community makes you better. And so you get to make people better, other people make you better, just continuous learning. And so I co-founded with Tom Ferraro that user group in Fort Collins called NoClug. Then I moved out to Massachusetts, and while I was at Bloomie, I founded the Mass Compilers user group out at Bloomie, and this still is running today. I'm not running it anymore, but they do a great job with it. When they used to have NI days in the States, there was an NI days Boston, and I worked with whoever was in NI sales at the time, might have been Heather Baker, to create this thing called the LabVIEW Craftsmanship Workshop, where every year, the night before NI Days Boston would start, we'd get together and invite all the CLAs and CLDs from New England and Canada that were close by to come. And there was just a 4-hour session that we called the Craftsmanship Workshop. And we talked about the solid principles, and we talked about kind of high level ideas and how to implement them in LabVIEW. And when NI Days Boston went away, that kind of went away too, because we lost our platform. And then for NI Week, for the started as the Champions track, and now it's the CPAD track. I was co-chair and chair a few years ago for that, and I co-chaired and chaired the CLA Summit. And so I've been maximizing my LabVIEW Champion license, right, to get in front of people and talk and help to organize events. And so I really firmly believe that me putting my personal time into the LabVIEW community makes me better, right? Just kind of selfish because I get better doing it, but also I hope it makes other people better too. Even just trying to organize these conferences is so much work. It's just, I didn't understand the amount of work it was, but it's worth my effort because it gets other really talented people in front of groups of LabVIEW developers and architects to talk to them. And so it's worth it. So yes, a rising tide lifts all boats, as they say. And anytime I get a chance to try to help that tide rise, I will do it.
Awesome, John. Like you have contributed a lot into the community. Like you said, you were like a chair and co-chair as well. That's how like we're having all this conversation and everything, like contributing back to the society and everything. Now, like I want to like ask a little bit different question. Like maybe like the standard of the quality of the code you guys are building over there. You are like developing the you are using your own libraries, your own framework, and then like a high-end like object-oriented programming, as well as the solid principles, agile frameworks and everything. But like a majority of the people, like let's say like you have also encountered the challenges. Let's say like you are supporting a customer, just like the example you gave earlier. So they are living in a bubble, and then now you are coming with a solution with like a very high standard application that is going to improve the longevity of the code. But at the same time, for them, not only they have to learn that, but like let's say like these people are not aware about the principle of the object-oriented programming or the solid principles. or even the agile and all this kind of stuff and everything. So what do you think, like how we can approach? We know that like you are a CPI as well. I think like this question is very relevant to you. So like how can we approach so that like introduce the LabVIEW to the people, so that like the beginners will not go into the bubble. So how we can approach it?
Yeah, it's not a simple problem to solve, right? So this is how we have done it, and we've had the luxury of teaching people that were invested in the success of our approach because they are our customers. So what we are able to do is bring our technology stack to their company and start solving their problem. And we do it by running sprints, and we try to make as many members of their team members of our sprint team as we can. And so they're on the team with us, and we give them a problem to solve. And of course, to start, it has to be a small problem. And so as an example, I'll talk about this in generic terms because it's customer related, but we recently finished a couple sprints where the goal was to develop a new product for a semiconductor industry. And we had one member of the customer's team on our sprint team because he's kind of their LabVIEW lead. And he is passionate. He wants to grow. He's learned that there's a better way. And so he wants to get better, and we want to help him get better. And so we bring all these tools that he has to now learn, and it's very overwhelming. But what we did is we bring the framework. Before we started the sprints, myself and another developer on my team, another architect, I just say developer because we write software, sat down and we kind of laid out the problem domain and how to solve their problem with our tools. We framed it out. And then we came and we sat down with this person right as the sprint was about to start. And we said, okay, you're going to be in charge of the spectrometer. This tool has a spectrometer. This is the main application. Here is the abstraction that we built for the spectrometer. And so this is, I don't want to go off on a tangent, but hardware abstraction gets killed. It gets beat to death. People do it for no reason at all. But we build these abstractions to kind of build this abstract API so that we can do dependency injection and dependency inversion to really handle separation of concerns and make it so the rest of the application doesn't have to know that, oh, this is this model spectrometer, this model MFC. We just know how to talk to a thing called a spectrometer within the domain of this problem we're solving. And so we sat them down. We said, okay, here we go. This is your abstraction. Your abstraction has to define an API. Make a list of the things your spectrometer has to do. You're the problem domain expert. We're the software domain expert. Let's work together. And so that was his task to start with, where he sat down, he defined what a spectrometer should do. And then we sat down with him again and we said, okay, here's what you think you wanted to do. Now let's build a public API. Nothing concrete, nothing to do with your actual spectrometer. Let's just build a very abstract public API that our application can call into. And so we showed him how to build the abstraction into the class hierarchy that he was working in. And the mechanics of doing that are pretty simple. They might be foreign, but they're simple. And so we walked through it with him and he was able to do it. Then he came back and he said, okay, I've got this API. And so we said, okay, now that we have a public API, we actually have to write something that does some work. And he was like, oh, thank you. We get to actually write something that does some work now. And so we showed him how to create the concrete class as a child of the abstraction, and we showed him how to override the methods and just the mechanics of working in this object-oriented world in LabVIEW. And again, it's not hard; it's just foreign. And once you've done it, it's easy. And so he sat down, he did it, he implemented it, and at that point, we had a functioning spectrometer that we could either run our software with the abstract version or with the concrete version. And he got to write some code, and that was his deliverable for that first sprint. And so you have to ease people in and you have to teach them what they're supposed to do because nobody knows things by default. And actually, that's a terrible assumption that most people have is, I just can't do it. Well, no, it's not that you can't do it. It's that nobody should expect you to do it at this point. It just isn't a fair expectation for you to be able to come into this cold and understand, just because you're part of the team. And so we try to bring people up into using our software by just kind of starting small and implementing stuff and doing a code review, showing them the code that we're writing, showing them how it all kind of fits together. And at the end of the day, we deliver a project that they had their hands in, and that helps them to feel a sense of ownership for, and they're able to understand how the pieces work. They haven't seen all the pieces. They didn't write all the pieces, but they know how the pieces play together to make this system work together. And once they understand that, now we can go away and they can debug it. If they find a bug, they can add functionality if they need to add functionality. This same customer just last week I was working with again because they needed to add an MFC to this project we had already delivered. And so he said, okay, I'm going to do this myself because I know how to do it now, but I want you to meet with me basically at one stand-up a day. And so for 10 or 15 minutes every morning, we'd get together, talk about what he wanted to do today. I'd give him my thoughts on how to do it and look at what he did yesterday and just keep that feedback going. And it doesn't take much of my time because it's just 10 or 15 minutes a day. And he was able to implement it. And so he is learning how to write really solid software, really clean, solid software that uses dependency injection and separation of concerns. He just doesn't need to know those words yet, you know? I mean, we say those words to him, but those words sound scary and it's not necessary. But he's doing it and he's learning it. And now when his bosses go to him and say, I don't understand why you guys are spending so much time on these things that I don't understand. He says, oh, well, because now I can do things like add an MFC. It's something that would have taken me weeks before I can do in 3 days, you know, because the software is flexible and built for change. And more importantly, I understand how it's built for change and how to change it. So it's making that investment up front, that investment in the software and also that investment in the people. In every project we've done over the last couple of years, we've had a person or people from the customer on our sprint teams working with us because you have to. But that doesn't really address your problem and your question entirely, because how do you do that outside of a professional engagement where we have a customer and we're a company? Like, how do you do that with the community? Great question. I don't know, because it takes time. It takes a lot of time. You can't just do it in a user group meeting, and you can't really do it across 5 user group meetings where there's a month between every meeting. There's no continuity there. I don't know. I'm not sure what the answer to that question is, because you need time, and both people, like I have to give my time, and the people who are working with us have to give their time, and they have to want to do that, which isn't always true either. Even people who come to user group meetings, they don't always come with the goal of contributing or even with learning. Well, sometimes people come with the goal of, I'm just going to tell them how I solve my problems, and I'm not really going to listen or try to grow. And that's just how people are, you know. I mean, I do my best not to act that way in that type of environment, but it's hard to not just be like, oh, well, this is how I solve problems. I always want to hear how other people approach things, because it will teach me something. I guarantee that. So I don't know. I wish I knew the answer. If you know the answer, I mean, you might know the answer because you kind of have built a company around this idea, right?
So, that's very interesting point, John. Like I've also encountered a similar kind of situation. Sometimes I am about to train a lot of people for LabVIEW best practices and then design patterns and all these kind of things. But sometimes what actually happens is some of the people will come around. They have got some project in hand, and they have reached the date point, and then they do not know what to do afterwards. So every time I'm explaining something to them, they're always only thinking how can I solve that problem using this information, and that way they're actually missing the point and everything. I think they become a little bit tunnel vision, and then they won't be able to see the larger scope. So at the same time, I'm highly excited with this, how the conversation is developing and everything. You are giving lots and lots of information to our viewers and everything. But at the same time, this is I want to be honest. This is the one of the most advanced, most technical interview I ever had so far. So for some of the people you have discussed about lots of solid principles, terminologies and everything. So many people who might be attuned to this one and everything. So if they do not know what are the solid principles, could you a little bit explain to them in very short form, so that they can understand, and then how I know that you can actually use the full potential of the solid principles in the projects you deliver at your compose system and everything. So what
Yeah.
what can you like tell to the customers in like a very short and easier way? Like what is the solid principles?
Yeah. So, so I gave a presentation on solid with Stephen Loftus-Mercer at NI Week a few years ago, and he started the presentation by saying this could be a complete course at a university, just discussing these ideas. And he's not wrong about that, because like anything, you can't soak it up. You have to actually do it. So the point of solid is to write software that is easy to change, right? So let's start with what I talked about first. Software has two values. The first value is that it's soft, and we want to write software that can basically change with the changing needs of our changing customer. And the second value is that it solves our customer's problem, because we all know that problem is going to evolve either throughout the life of the project or 6 months later when they have to change it. So how do we actually write software that is soft? We want to focus on writing changeable code. So the S in solid is a single responsibility principle. And that says that every class, every module, every component that you write should have one reason to change. And when it has one reason to change, it becomes easier to change your software without breaking things, because it should be easy to identify that one thing that has to change, and nothing else should change with it. It should change by itself. I could go through them all. O is for OpenClose principle, and that's essentially what we talked about before, where we want to have this abstraction, and then we want to be able to have concrete implementations beneath it. And so how we use that a lot of composed systems is we will use OpenClose to write an interface, an abstract interface that defines a public API. And we do that because our application shouldn't have to know how the implementation details are handled for any of the business logic. And like a spectrometer, the application doesn't want to care or shouldn't care how the spectrometer works or what spectrometer it is. Just certain parts of the application are going to want to request that the spectrometer do certain things at certain times. So we build this API, and that API has to be written in a way that we don't couple the things that need the spectrometer to the spectrometer itself. We want to keep that decoupling. And so OpenClose helps us to do that. L, Liskov substitution principle. Essentially, you should be able to substitute any of the subtypes for the supertype. And so we don't want to create a top-level class that has lots of overridable methods that all the children don't need. If you do, that's kind of a code smell, that you're doing something that could be done better. What do we have left? You put me on the spot. The dependency inversion principle is probably my favorite one, and I kind of mentioned it before, where you want to manage how things depend on each other, especially in LabVIEW. So my opinion, and I'd love to talk to other people about it, and I do love to talk to other people about it, is that the dependency, the LabVIEW IDE, one of the reasons that people see slowdowns is because they're not managing their dependencies correctly. They have modules depending on other modules when they don't realize it. And LabVIEW trying to link all these things together causes LabVIEW to slow down. And I've seen really big projects with really poor dependency management where the IDE basically grinds to a halt. And what do people say? They say, oh, LabVIEW sucks. You know, I can't write big applications with LabVIEW. But just like anything, it's not the tool that sucks. It's the person using the tool that's making it suck, right? Because they're not making the right decision, right? And so that's a big one for us. And so we use dependency injection as a way to get around that, where if you look at our code, and you can because all these things are open source, the way that we write our code is when we spin the whole thing up, we basically have an assembler where we inject all the dependencies into the things that need the dependencies. And that's true for the business logic, for the models, as well as for the views. And so we have this thing called the MVA framework, which is just a big separation of concerns pattern built on top of the actor framework. And it handles decoupling views from models, which is a pretty normal idea that's everywhere outside of LabVIEW, right? If you go and you try to write some JavaScript code or anything else, you're going to be able to use these things that are kind of built in, these ideas. And so we use the MVA framework to separate concerns between views and models, and we use dependency injection to compose our views and our models by injecting the dependencies where they should be. So we have really tight control over the different dependencies within our software. And that flows into how we structure the software on disk even, and how our projects look, where we try to manage our dependencies at inside the editor, not only in that runtime when we actually run the thing, but in the editor too, so that we don't kill LabVIEW with these big applications. And our applications tend to be pretty big. We have lots and lots of classes, lots of libraries. But it all works when you do it well. And so these ideas in Solid are all geared towards writing changeable code, right? And I started by saying the one thing I care about as an architect is being able to plan for change and to manage change. And these ideas help us write tools that help us manage change. And that's really the whole idea behind why we write the software that we write. I gave a presentation at a CLA summit a few years ago, and I kind of harped on this idea that easy and simple are very different things, and hard and complex are very different things, right? It might be, let's see, what's a good example? I don't speak Japanese, right? That doesn't mean that Japanese is a terrible language just because I don't know it. It just means that I don't know Japanese. And so Japanese is hard for me, but it may not be complex, right? Same can be said for like working on an engine in a car. I'm not an auto mechanic, and so I don't know how to do it. But that doesn't mean that well, it might be complex, but it doesn't mean it has to be complex. It just means that it's hard for me, and that's true with software, right? Based on what we know and what we've learned, we might just say something is hard, or we might say, oh, that's too complex. Your solution's too complex. It's not. The solution is hard for you, but in reality, the solution is simple. It makes the problem space simple. And that's super important to keep the problem space as simple as you can, and to keep the way that you structure your code in your project or projects as simple as you can. Because keeping the code simple means that you can change it and it can grow, it can be maintained. And keeping the project simple means that you don't lock up your IDE and you don't want to kill LabVIEW. I mean, sure, we all want to kill LabVIEW every once in a while, because my favorite is when it'll start acting weird, and then you go to shut it down, and it gives you that message that said, oh, hey, I crashed a while ago. Here's the report. I've just been running in a wonky state for you for the last hour. So Solid is a bunch of ideas that help you write simple code. And that simple code is made simple by separating concerns and by managing dependencies. And we do that using object-oriented programming and taking advantage of abstraction in the right places. People tend to use object-oriented programming in strange ways, in my opinion. We try not to solve every problem with inheritance, because that doesn't tend to be a clean solution. We try to use composition more than inheritance, and we try to use dependency injection to handle and manage that composition in a smart way that helps us to manage our dependencies. These ideas seem weird to talk about because it's a bunch of weird words, but it's not that bad. It may not be easy if you're not used to it, but I guarantee you it's simple, and that's important.
Wow, really, really important point, John. Like, many people, I think, like many people who are tuning into this interview, or many people who were like, doubting that like a LabVIEW is like a full-fledged programming language. You have just proven that like you can implement everything you can use with any other like a generic programming language, like a C, C++, or Python, or anything, like a solid principles and everything. These are all the very advanced stuff and everything. So, John, like you have been using LabVIEW for a long, long time and everything. So, LabVIEW from the beginning, and then like now, like we had got new features. It can now like use the code in like written in many different languages, including Python and everything as well, which is like getting there. Like it has been leading the programming language chart and everything. So we have also now like NI has also introduced the like NXG as well, the next version of LabVIEW next gen. So where do you see like the future of LabVIEW? Like, are you very much excited and everything where it is going, or you still believe that like some of the things are missing over there, or maybe like LabVIEW champions like you, like who is actually like putting everything that is in the software engineering concept and like building your own frameworks and everything. So what do you see the future?
So it's a big question. So, okay, let me state this. I think one of the biggest hurdles, one of the biggest problems with the future of LabVIEW is that it's not free. And that's kind of a weird thing to say because I don't work for NI. I never have worked for NI, and I understand it's part of their business model to sell LabVIEW. But look at what LabVIEW competes against. It competes against Python. Why are people able to learn Python in high school? Because it's free. They can sit down, they can just download it and use it. That is a huge problem for LabVIEW, is that it costs money to be able to play. And I think that that's going to really hurt us long term because it's going to minimize people who are coming up learning how to write software, seeing LabVIEW and trying to use LabVIEW. So that's an issue. I don't know how to, well, I mean, you solve it by making it free, but I obviously have no power with anybody and no sway with NI, and I'm sure they've got no reason to do it. So that's the first thing that I wish would change, was that LabVIEW would be free, and then people would get exposure to it early on in their careers before they build up biases against graphical programming, and they could see how awesome it is. I'm looking forward to NXG for a bunch of reasons. I think that, so I'm excited with what they're doing with the NI package manager. We have at Compose Systems started using the G package manager from MGI, and we like it a lot. All of our tools I've been mentioning to you are open sourced, and you can go and get them from the G package manager. If you just search on @CS, you can go and find everything. I like the G package manager because it allows you to pull down the reuse code version that you want and attach it to a project, and it doesn't get installed in VI-lib, and once it's in VI-lib, everything has to depend on the same version. With G package manager, we can actually just pull down the right version for that project, and it can persist with that project. So that's really nice. I'm looking forward to things in NXG, like how they're handling components. I don't love packed project libraries. I don't think anybody loves packed project libraries in current gen. I've used them extensively in the past because, so what I do love about packed project libraries is you cannot write an application that does not follow the solid principles with packed project libraries. It forces you to write clean code, which is awesome, but you have to build a bunch of your own tooling up around PPLs to make it worthwhile, and that takes time. I think that the way they're going to handle components with NXG will make it more accessible and easier to write solid software, so that's awesome. There's this idea of traits and mix-ins, which will allow you to solve hard problems without inheritance, the way you might have to try and do it today. And there's some talk of that being ported to current gen. I know there's talk about putting it into next gen as a first-class citizen. I would love to see it in both. I would love to see it in current gen so we can use it today. And I'm excited to see it in next gen, or NXG, sorry, NXG, so that we can use it in NXG. There's new features like malleability, which give you really powerful edit time polymorphism that we're taking advantage of. We actually went through over the last 2 months and we refactored almost all of our reuse code to use malleable VIs in certain cases. We've got this sequencer, which is really nice. It allows you to sequence anything. It doesn't care what's being sequenced. And so what's being sequenced is part of.
So talking about malleability. Yes. And so the sequencer, yes. The sequencer lets the problem domain own what's being sequenced, and it just knows how to sequence whatever. And it lets you build these flow control things. And so you can do looping and case structures. You can have pointers for data in sequence. You can have a parallelization of things, so it'll go in branch. It's kind of like test stand without test stand, which why, right? I mean, why not just test stand? Because it costs more money and deployment is a nightmare. So we have this sequencing tool that we decided we never want to write this again, so let's just make it a tool. And we brought malleability into it. Over time, we had built up our own typing system inside the sequence because we had to be able to instantiate types of data and let customers create new types of data that weren't just, doubles, singles, I32s. Malleability lets us dip that whole typing system. And so before, where we had to have basically a class hierarchy of different data types, now we can use malleability and use edit time polymorphism just to get rid of that whole structure. It really cleans up the code a lot. We also have brought malleability into the MVA framework because you're just passing data types around on a message bus. And so we try to bring these new ideas that are in current gen and in some form in NXG or next gen as well, NXG, and use them as they come available. And so that's kind of what I'm looking forward to in NXG and kind of what we're doing with current gen to stay on top of new features.
Wow, that's really like interesting points you have put, like John. So I have also like encountered that LabVIEW on the since it is a little bit expensive to start for the students and everything. I think that is a barrier. So that is my point as well. Like I agree with you. So John, you have been coming back to the community as well. As we know that we have been you have been presenting it and even coordinating for a different CLA summits and everything. So I believe that you are traveling for the NI week coming in a few weeks time, and you will be presenting as well. So can you tell the audience that what you will be presenting on and where they can find you in Austin?
So this will be the first NI week I haven't been to in the last 7 years. I'm actually not going this year.
Oh wow. Okay.
And partly because I spent so much time on NI week between chairing and co-chairing the CPAD summit the last 2 years, and also because my daughter's birthday happens during NI week and I missed it. And so for mostly personal reasons, I'm skipping this year's NI week, but I will be at the CLA summit in Austin this September. I'm working on a presentation proposal for the CLA summit on the epistemology of software engineering, which kind of would cover this conversation. Like how do people learn, and what prevents people from learning? How do you know what you know, and how do you know what you know is correct when it comes to writing software? If I do this correctly, I want this to be the kind of presentation where people are standing up screaming at me by the end saying I'm wrong, and that each other are wrong. Because those are the best kinds of presentations where we actually pick fights with each other.
Yeah, very interesting. Yeah.
So that's what I'm aiming for, is I want to have a conversation, and I want to kind of tailor it towards frameworks and architectures and talk about designing for change as a first-class citizen of the approach, instead of saying, I'm just going to write this code and plan to change it later, even though it's a complete refactoring effort. So how do you write for change from the start? Should we be writing for change from the start? Why I think it's okay to solve every problem with our frameworks. People will most likely disagree with that statement, but I want to have that conversation too. So that's what I'm aiming for at the CLA summit. Hopefully I have enough time to put it together, and hopefully it ends up being a knockdown, drag out fight with everybody. Those are the best kind of presentations.
Yeah, I think they would be overwhelmed, and then they will actually love these kind of presentations and everything, because most of the time people will focus only on the technical side and not on aspects of how people view, and then they understand the problem and then tackle and everything. John, we can continue this a conversation continuously, as many things as we can roll on and everything. I learned a lot from you. I think our audience also enjoyed this conversation and everything, your entire journey with LabVIEW and all these kind of things. So John, what do you want to, in the ending note, what do you want to tell to our audience as well as the other LabVIEW champions? I think the news has been spread that will be coming up next, and then you have seen some of the videos. So what do you want to tell to your fellow LabVIEW champions as well as the CLAs who would be attending your a CLA summit, and probably your colleagues at your firm as well as the NI folks as well? So what do you want to tell to them? And then finally, where if any people from the Boston area, if they want to take your services, how they can reach you out?
Yep. So I guess start with the latter. So you can just go to composesystems.com and you can find us there. We also curate the.
Yeah, I'll also put your link below. Yeah.
Okay, perfect. We curate the LabVIEW Craftsman blog. So if you Google LabVIEW Craftsman, you'll find our blog site. It's becoming more active now. It was kind of dormant for about a year. But that's what happens with small businesses is you get super busy. We're trying to make the effort to keep putting new information up there. And we invite people from the community to contribute as well to that blog. So if anybody is interested, find me on LinkedIn, or you can contact us through the website. We would love to host your content on the blog. It's got a pretty good readership. What would I say to the community and to everybody in general? That's a great question. So like I started with, I think our primary job as architects is to manage and to plan for change. And I would keep harping on that, and for people to keep thinking of solving problems that way. Plan for change in both how you write your software and how you interact with your customers, with your coworkers, with your bosses, or how you approach everything. Plan for change. Change happens. You have to embrace it. If you don't embrace it, it's going to kick you. Another point that we kind of touched a few times was everybody's in a bubble, everybody, and do your best to find the boundary of that bubble and pop it and get outside. I think that it's probably bubbles all the way down, and you just got to keep popping those bubbles and keep learning new things. And that's super important. You can't let yourself stagnate. So for me personally, when I get stagnant, I become unhappy. And that's a good motivator for me to not be stagnant, to keep learning. So just do your best to find that bubble and pop it, whether that's finding a user group to become a part of, or finding a user group to become a major contributor to, presenting at NI Week, going to a CLA summit, presenting at a CLA summit. These are all great ways to pop that bubble and go and learn from other people and teach other people. That's the only way that LabVIEW is going to keep growing. The community is going to keep growing and getting better. We have to take ownership of the success or failure of LabVIEW as a community. And we can do that by contributing and by helping everybody grow. I think that's all I have to say about that.
Wow, thank you very much. Like a very, very inspiring notes, as well as a very highly technical conversation I had with Jon McBee. Thank you very much for sharing your valuable time for our viewers, Jon. Thank you again. Thank you. Thank you very much. Next time, we'll be speaking with another LabVIEW personality or the LabVIEW champion to explore their journey with LabVIEW and how they are making difference in LabVIEW application development scenario. Okay, I'll see you next time. Thank you very much for joining us for this very exciting interview. Thank you very much. Yes, Jon, I ended the interview. So how's your experience?
Oh, it was good. I apologize for the technical glitches on my side. That was